Okay, in this video we're going to discuss quadratic inequalities. So these are quite a lot like linear inequalities, but you've got the added problem that we have to deal with the quadratic formula as well. So, first thing I'm going to do is, when we're looking at this, instead of solving it for less than, I'm going to solve it for equals. So, x squared plus 3x plus 2 equals 0. Now what this is going to find me is it's going to find me their critical values. So this will give me x plus 2, x plus 1 equals 0. The critical values are the points where we cross the axes, and we want to be on one side or the other side of those. So we get x equals minus 2 or x equals minus 1. If I draw this, minus 2, minus 1. Good habit to always put these in. We want, that's it, we've drawn it. But what we want is we want it to be less than 0. So all the way along here, the line is above 0. And along here, the line's above 0. So we need to be in this region here. This is good workings as well. So we know that x needs to be smaller than minus 1 and bigger than minus 2. And that's it. That is our answer for the first one. Now make sure that you are always in the correct region in here, and that this symbol and this symbol are the correct way around. Okay? But that's it. That's all we have to do for these sort of questions. Okay, moving on to the second question. Right, this time we're going to have to do some rearrangements first. So I'm going to bring this 5x plus 3 over to the right hand side. So I'm going to get 0, no, I want to do that in black, 0 smaller than 2x squared minus 5x minus 3. And again, I'm going to change it over to be equals. I'm then going to factorize it. Okay, then I'm going to get x equals minus a half or x equals 3. Okay, remember, those are our critical values. We haven't finished yet. So we're now going to draw this. This is minus a half. This is 3. Right. This time we want these numbers to be bigger than 0. So rather than being in this region, we want to be in this region here. So we know that x must be bigger than 3 or x must be smaller than minus a half. Okay? And those are our answers again. Okay. Moving forwards. Okay, this one, again we're going to set it to equal 0. So we get 0 equals 7 minus 5x minus 2x squared. We could swap everything around to the other side to get rid of the negatives. I'm not going to right now because I want to show you this method. Okay, but what I am going to do is I'm going to bring a minus out. 2x squared plus 5x minus 7. So that is and we need that one to be 7 and that one to be minus 1. Yep, there we go. So we find that x equals minus 7 over 2 or x equals 1. Those again are our critical values. Now this time we're going to have a graph that looks like this. That's 1, that's minus 7 over 2. No, it doesn't matter that these graphs aren't very accurate. They're just there to help you with your workings. So we want all of this to be bigger than or equal to 0. So we want this region. Okay, so we know that therefore x must be smaller than or equal to 1. Got to be careful, remember, make sure those equals to's are in there. And bigger than or equal to minus 7 over 2. There we go. That's the third question done. Okay, this one is a bit tougher. It doesn't really look at the moment like it's an inequalities question. However, we're asking for real roots. Now, if you've got real roots, what you know is that b squared minus 4ac must be greater than or equal to 0. Right? If it's greater than, it has 2 real roots, and if it's equal to, it has 1 real root. But both of those situations are real roots. Now in this case, b equals minus k, a equals k, and c equals minus 3. So we've got to plug all of those values in. So you get minus k all squared minus 4 times k times minus 3, and that's bigger than or equal to 0 still. So we get k squared plus 12k bigger than or equal to 0. Now again, I'm going to set it to be equal. K squared plus 12k equals 0, and solve this side. K plus 12 equals 0. So we get k equals 0, or k equals minus 12 as our critical values. When we draw it, right, that's our 0 point. Y x, that's minus 12. Now, we wanted b squared minus 4ac to be bigger than or equal to 0. So we wanted this to be bigger than or equal to 0. So this had to be bigger than or equal to 0. So we want to be anywhere along there or there. So now we get that k must be greater than or equal to 0, or k must be less than or equal to minus 12. And there we go. That is the setup for how we deal with these styles of questions.